Welcome back, this is Mr. Tipton, and today we are writing linear equations. Our goal when we're graphing is to have things in slope-intercept form. That's one of the easiest ways that there is to graph lines. We don't always have all of the information that we need in the form that we need it. So a lot of what this video is about will be taking that information and learning to manipulate it until we get it into slope-intercept form. The form that we need to get it into slope-intercept form is right here. It's called point-slope form. And it's exactly what it sounds like. When we know a point and when we know the slope of the line that we're dealing with, we can put that into this formula and do some solving and come out with something that we can graph. Let me show you what I'm talking about. There's a line and it includes the point 0, 9, and it has a slope of 9. Write its equation in slope-intercept form. Okay, in a previous video we knew what the y-intercept was, so it was really easy to write in slope-intercept form, but we don't know where the line crosses the y-axis. We just know that there's a point. Okay, bad example. We do know where this one crosses the y-axis because the x is 0. So forget I said that for a second, and I want to show you how to manipulate point-slope form so that we can get the equation in slope-intercept form. Alright, so we're going to plug in what we know. This is the point that we have. So we have y minus y1. The y of our point is 9. M is our slope, which is also 9, and x minus x1, the x of our ordered pair is 0, and we're going to leave our left side alone for a second, and we'll distribute on the right side. 9 times x is 9x, and 9 times negative 0 is 0. I'm not even going to write it down. Now remember, we're trying to get to slope-intercept form, which is y is equal to mx plus b. Okay. Basically, it means we need the y by itself, followed by the mx. The mx should be the first thing on the right side of the equal sign. But for right now, we've got to get rid of this negative 9 so that the y can be by itself. Now on the right side, remember we've got a 9x and a 9. Those cannot be combined because one has an x, the other one doesn't. So what do we have on the right side? Well, we've got the 9x, and we also have a 9. Here is our y equals mx plus b. This is the equation of the line in slope-intercept form. Let's do another. Here's a line that includes the point 5, 3 with a slope of 2. Write its equation excuse me, in slope-intercept form. It's our goal to get here. That's what we're trying to get to. Sub in what we know. The y value of our first point is 3. Slope is 2. The x value of our first point is 5. And we leave the left side alone so we can distribute on the right side. 2 times x and 2 times negative 5 is negative 10. I'm going to add 3 to get the y by itself. And remember, I can't add the 3 to the 2x. There's nothing happening with the x. It's still 2x. But I now have negative 10 plus 3 is negative 7. Y equals mx plus b. Right there. That's our goal. Slope-intercept form. Real easy to graph when it's in slope-intercept form. Alright, here's a problem where we're not even given the slope. We're just given the 2 points. The line includes the points 6, 2 and 9, 8. Write its equation in slope-intercept form. It's a nice thing that we know how to find slope. Okay, in a previous video we talked about y1 minus y2 over x1 minus x2. Call this one point 1 and this one point 2, and we'll have 2 minus 8 over 6 minus 9. Going to give us -6 over -3 for a slope of +2. Right? And remember, this is our m, this is our slope. So now we know we can use point slope because we know a couple of points and we know the slope. Y minus y1 is equal to m times x minus x1. This is point slope form. It does not matter if you use point 1 or point 2 when you do this. I'd pick the one with the prettiest, easiest, smallest-ish numbers. I'm going to use point 1. Point 1, let's see, my y is 2. And we figured out the slope of my line is 2. And my x is 6. So that's going to give me y minus 2 is equal to 2x minus 12. And I'm going to add 2 to both sides. So my equation in slope-intercept form will be y is equal to 2x minus 10. Okay? We need slope-intercept form. Use what we know to get there. Here's another one with 2 points. Let's find the slope. y1 minus y2 over x1 minus x2. I'll make this 1 and this 2. Looks like we've got 2 minus 10 over 0 minus 2. Gives us -8 over -2. Our slope is 4. Because I know my slope and I know at least one point, I can use point slope form. And I'm going to use point 1. Got smaller numbers. M is 4, X, oh, and a 0. Nice. Zeros are easy to work with. 4 times X is X. 4 times 0 is nothing. I'm not going to write it down. But I am going to add 2 to both sides. Not going to combine it with the 4x because one has an x, the other one doesn't. Y is equal to 4x plus 2. Couple more, I think. Oh, all right. Rewriting slope-intercept form. This is currently it's in standard form. That's a standard form. Standard form is ax plus by equals c. X and y are still your points on a graph. A, b, and c are, well, the other numbers that are there. We're going to rewrite it so that it's in slope-intercept form, though. Okay. Almost always, our goal is slope-intercept form. Y equals mx plus b. That's how we graph stuff. So over here, what we need to do is we need to get this y all by itself. So, save the term with the variable for last. Let's start by getting rid of this 3x by subtracting it from both sides. So on the left, I now have 4y. And on the right, the -12 does not have an x. The -3 does, so I cannot combine them. And I'm going to go ahead, and I know I'm trying to get mx plus b, so I'm going to go ahead and put my -3x right after the equal sign. I could have done 4y is equal to -12 minus 3x, but remember slope-intercept form, mx plus b. We need our x's to be right after the equal sign. Get rid of all that. Back to the pen. We'll keep going. Need to get y by itself, so we're going to divide by 4. Okay. When we do that on the left, the 4 goes away, and we're just left with y. Now we have to divide everything by 4. All terms get divided by 4. That means our slope, we're not going to make a decimal. We're going to leave it as a fraction. -3/4. It's our rise over run. This would be a negative slope. Do not make it -0.75. Don't do that. And then negative 12 divided by 4 is negative 3. There we go. Slope-intercept form. Y is equal to, that was supposed to be an arrow. Y is equal to negative 3x minus 3. And I think we have one more. Yeah, just another one where we start in standard form and our goal is to get into slope-intercept form. Get the y by itself. Get rid of those x's. Put them on the other side. What you do to one side, you must do to the other side. And now get rid of that 6. Everything gets divided by 6. So we're left with y is equal to negative 3x plus, that's kind of an ugly y-intercept. We're going to reduce it 5/3. Yeah, so if we were graphing that, we'd have 1, 2, 3. Okay, the y-intercept, 6/3 would be 2, so 5/3 would probably be, somewhere there-ish. And with a slope of negative 3, we'd go down 1, down 2, down 3, and then over 1. So that line, if I drew it straight, would look something like that. It wouldn't be going nice and prettily through a whole number. Alright, but that's some equation solving. That's point-slope form. And just writing linear equations, manipulating them into something useful. Alright, if you have questions, keep track of them. We'll see you soon.